going to remind this. So a test for just a regular trapezoid, which is kind of what you're asking me, Casey, is that you find the slope of all four sides.
No, right, that's what I did, but
I know. So you're finding slope wrong. So that's what we have to deal with. That's a pink sheet, not purple. Find the slope of all four sides.
There is no purple.
Only one set of opposite sides can be parallel.
I don't. I mean, I missed days before, so.
Wow, you didn't even read it.
I know I don't have that. I've never gotten that.
Stop talking. I know.
then you told me.
I was getting one. I knew what he was saying the whole time. I was trying to get him one.
No.
All right.
He asked.
So, the first thing we did that, if we wanted to test if it was isosceles, we had to then check, after doing all of that, we checked to see if the diagonals were congruent with distance. Because I'm reminding you, here's the deal. You guys have a quiz tomorrow at the beginning, Thursday at the beginning of class. Why am I writing this? Because trapezoids could be on your quiz tomorrow along with parallelograms. So I'm trying to remind you guys of how we tested for trapezoids so that if it asks you on your quiz tomorrow if this is a trapezoid, isosceles trapezoid, parallelogram, or just a quadrilateral, you can answer that question. Do we understand that? Also, you are going to be learning. So we've learned 3 shapes. You're going to learn 3 more, which means you're going to need to know 3 more tests after today. So keeping all of those things separated is going to be super duper important. Okay.
Whoa.
Okay,
You good. I don't.
Stop. Seriously.
How'd she not get her phone?
Just stop. Okay. So how do we find the intersection of the diagonals of a parallelogram? Well, the intersection is going to be the midpoint of those pieces. So we are going to do the midpoint of each diagonal. No, midpoint.
Oh.
Do you see how I said that? So remember, to find the midpoint, you add the x's together and divide by 2, and you add the y's together and divide by 2. So we are going to be doing the midpoint of each diagonal to see where they intersect. So what is one of my diagonals, Greg?
SU.
So we do the midpoint of SU. So we add the x's together and divide by 2, and add the y's together and divide by 2. So it is at -1, 5/2. So that is the midpoint of SU. What's my other diagonal? What is my other diagonal? TR or RT, it doesn't matter how you want to say that. So you add the x's together, divide by 2, comma, add the y's together and divide by 2. And what are you noticing as we're doing this? What do you notice?
For us, use a 3/2.
That's a 5/2. So what do you guys notice? They're the same. Isn't it where they are supposed to be meeting? So that makes sense. It is not a trapezoid. We just found the midpoint. So this point here is at -1, and you guys will notice this more as 2.5. So that we're saying that point is at -1, 2.5. We found the midpoint of the diagonals at -1, comma, 2.5 or 5.5 or 5/2. So that's what we found there. So we know the diagonals bisect each other, so they should meet at the middle point of each one of those lines. That's all that's saying. All right. When you're ready, you can flip to the next one so we can talk about the tests that we'll be doing. We're not actually going to be doing all of those tests. We're actually not even going to be doing one of those tests. I'm going to show you which one I want you to do. So on your purple sheet, do you guys see the big parallelogram at the top? When I write down the steps for how to do the test for this, that's where you can write it, all right? All right, so here's how this is going to work. So there's different ways you can prove that something is a parallelogram. You can prove that both pairs of opposite sides of the quadrilateral are congruent, meaning that you would use distance. We are not going to do it that way. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram, which is what we just did on the previous slide. You see how we found the midpoint of each diagonal, and it had the same midpoint? That meant that it was bisecting, so that's a way to do it. Another way you can do it is if both pairs of opposite angles are congruent. Well, we can't prove that from a graph, so we're definitely not doing it that way. And then one pair of opposite sides is both parallel and congruent, which means you just choose a set of opposite sides, prove that it's parallel, prove that they're congruent. We are actually not going to do it that way. What does it mean to be a parallelogram? Who remembers the definition of a parallelogram? From yesterday. What is the definition of a parallelogram? That's a quadrilateral. What is the definition of a parallelogram? What word is in parallelogram? How many? You're not wrong. But the word parallel is in there. So what is the definition then? With two sets of opposite parallel sides, right? So we are going to use the definition of a quadrilateral, and we're going to find the slope of all four sides. And then after we do the slope of all four sides, so hopefully Casey doing the slope today will help you figure out that stuff. So slope of all four sides, and then you're going to check opposite sides. Are parallel, so they have the same slope. Yep. And in this case, you need to make sure that both sets of opposite sides are parallel for it to be a parallelogram. What is it if only one set of opposite sides is parallel? It's a trapezoid. So we have to keep those separated. We know that if we find one set of opposite sides parallel, it's just a trapezoid. But if both sets are parallel, then you are getting to a parallelogram. And you can see from your chart that that parallelogram is going to branch off into a lot of different shapes there. So we are going to continue our tests for parallelograms throughout the week. Not this week, but throughout the next few weeks. All right, when we're ready, we're going to get started with that first example there. And this is very similar to what we did with the trapezoid. Didn't we find the slope of all four sides at the beginning of a trapezoid too? So that doesn't really stop where we're starting from, which is really nice that you can kind of determine from there. All right. Determine whether the figure below is a parallelogram, trapezoid, isosceles trapezoid, or just a quadrilateral. So first tell me, what are my opposite sides, Hunter? Give me a set of opposite sides.
YR and ZP.
YR and ZP. So we have to check if opposite sides YR and ZP are parallel, right? What's my other set of opposite sides? Go ahead, Greg.
PZ and YR. Or no, wait. No, you just did that. ZY, PR.
ZY and PR. So the first thing we're going to do is determine our opposite sides. So we know which ones we're trying to check to see if they are parallel. So Y is at -5, -7, and R is at 1, -2. Okay, so here's how you do slope. You do Y2 minus Y1 over X2 minus X1.
Oh my god.
You're not allowed to wear masks in school.
Oh my.
Like, they can get in trouble for that.
Why are they just like walking around?
Because I
don't know.
can't see anything.
Anyways.
One time I can see.
I know, it's creepy. All right, so listen, please. Casey, you really need to be paying attention. So -2 minus a -7 over 1 minus a -5. So that becomes addition. Shh. So that is 5 over 4. Stop talking. Take your hoodie off first. It's not that hot in here.
It isn't even really hot at all. I'm kind of cold.
I mean,
Do you need to go to the nurse? Are you
I
sick?
don't know.
I think it's
I-
slightly warm.
No, it's not that hot.
All right. 3 minus a -2 over 2 minus a -4 becomes addition. So I have 5 over 6. So are those slopes the same? Did I do them right is what I gotta ask myself next. I got 5. They should have the same slope, so I did something wrong. That's because I decided that 5 plus 1 is 6. So are opposite sides parallel so far?
Yeah.
So this, so far so good. We have one set of parallel sides. So now we do ZY. So Z is at -4, -2, and Y is at -5, -7. So we have -7 minus a -2 over -5 minus a -4. Please ask questions if you're confused on how I'm doing anything. So I add that, and that is -5 over -1. Yes. So that is just 5. PR is 2, 3. And R is 1, -2. So I do -2 minus 3 over 1 minus 2. And I get -5 over -1, which is also 5. So do we have two sets of parallel sides?
Yes.
So what do we have here? It is a parallelogram. It's also a quadrilateral. It's always a quadrilateral if it has 4 sides. It is not a trapezoid.
How much do we need to put quadrilateral to?
I think you're supposed to say all that apply, so yes. So what questions do you have so far on that one? If you need to go to the nurse or something. Because I'm worried that maybe you're not feeling well.
I never feel good.
say it, yay.
Yeah, I think I just got like the additional.
Okay, so do you think you can go back and fix it now? Okay. All right, next one. Determine whether the following figure is a parallelogram, trapezoid, isosceles trapezoid, or quadrilateral. So first we need to determine our opposite side. So Hayden, give me an opposite side. So we're going to check that PF and ST are parallel. Abby, what's another set of opposite sides? PS and FT. Okay. So I have 3 minus 1 over negative 1 minus a negative 5. So that is 2 over 4, which is a half. T is 2, negative 2. So I have negative 2 minus a negative 5 over 2 minus a negative 4. So that's 3 over, which is also. So far we have one set of opposite sides parallel, right? So we now need to check if the other set of sides is parallel. So PS is negative 5, negative 1, or negative 5, 1, sorry. And S is negative 4, negative 5. So I get negative 6 over 1, which is just negative 6. Negative 1, 3, 2, negative 2. So that's negative 2 minus 3, 2 minus negative 1 is negative 5 over 3. So are these sides parallel? Are those ones parallel? So what shape do we have so far? It's a trapezoid so far. Are we done? What do you have to check if it's a trapezoid? If it's isosceles. So now we have to check our diagonals. So, I don't know what I was about to say. Logan, what is one of my diagonals?
PT.
So we're going to find the distance of PT. So the change in X from P to T is 7. The change in Y from P to T is 3. So is that 2 root 13? Is that right? No, that doesn't look right. That's because 26 doesn't go in that. That should be 29, shouldn't it? Yeah. So nothing goes into that. So that's just the square root of 58. All right. And then what is my other diagonal, Carmichael? So F and S have a change in X of 5 and a change in Y of 8. You're right. Thank you, guys. So that's 9 plus 64, which is the square root of 73. Are those the same? No, so we just have a trapezoid and a quadrilateral. Okay, questions on that before I skip some? Do you have any questions on determining parallelogram versus a trapezoid and an isosceles trapezoid, Gabe?
So we don't have to say why it's a trapezoid quadrilateral.
This proves it. Okay, so all of your work is why.
Where'd you go?
All right, so let's go to the slide that has this stuff in it here. And we're going to skip a couple examples. Stop. Okay, justify whether the following quadrilaterals are parallelograms and explain why. Here. It's distracting me.
I literally just was checking one thing.
Okay. So, what is that first image there, a parallelogram, Helena? Why? It is a parallelogram because what? You don't know the opposite sides are parallel.
They're the same number.
They are congruent. Be careful. So, I'm sorry. So, first of all, you need to realize that these are marked congruent, not parallel. But if you have two sets of opposite sides congruent, then it's a parallelogram. Is the next one there, Devin, a parallelogram?
No.
Why not? What do we know about consecutive angles of a parallelogram?
They're supplementary.
They're supposed to be supplementary. I just don't know what word. I don't even know what word I just said there. So I get 170 when I add those together. So is that supplementary? No, so not. And that's because consecutive angles are not supplementary. So practicing explaining why. You have to explain why. You have to know how to explain why for tests and quizzes. So make sure you're practicing that. When you're ready, you can flip to the next slide. Is the next one a parallelogram? Is the next one a parallelogram? Jill?
No.
Are opposite angles congruent? Technically, I feel like this should be marked like this, but are opposite angles congruent? Yeah, so this is a parallelogram because opposite angles are congruent. Both sets of opposite angles are congruent. Let me get you the homework. No, you don't have a pass. Okay, we are going to backpedal to one of the very first slides we did real quick. And one of the things said, if one pair of opposite sides is both parallel and congruent, meaning that this one here is saying that you need to know that the exact same side is parallel and congruent. Then you know it's a parallelogram, okay? So if we go back to this example here, is it the same side that is both parallel and congruent? No, so you do not know that this is a parallelogram. It has to be the same side, has to be the same opposite sides, parallel and congruent. Are you trying to break my desk?
You did.
Stop.
I'm not breaking the desk.
They do break, so be careful, please.
Can I get a drink?
No, yes, sure. All right. Get that written down, and then we will move on to the next examples there. Stop. So solve for x and y so that each quadrilateral must be a parallelogram. So for this quadrilateral to be a parallelogram, what do we know about our opposite angles? They need to be congruent. So we need to set them equal to each other to find x and y. So if it's going to be a parallelogram, opposite angles must be congruent. Where? Yeah, sorry. Okay, so questions on the first one to show that that one is parallel. Or not parallel, sorry, a parallelogram. Finish the word. So what do we need to know then Austin, for number 2 for that to be a parallelogram? Opposite sides have to be equal. So we have 2x plus 3 equals x plus 7, and 3y minus 5 equals y plus 11. All right, questions on either of those two? We only have one more slide. Then you get your phones as well as your homework. I know you're more excited about the homework.
You can just keep it.
I feel like you've been trying to get me to think that I should steal your calculator, but I've already taken your phone.
No, he's doing everything and he doesn't want to.
Solve for x and y so that each quadrilateral must be a parallelogram. What do you know about the diagonals of a parallelogram? The diagonals need to.
I'll see.
Lindsay said it earlier. The diagonals need to.
Bisect.
So diagonals bisect each other. No, we're not doing that right now. So that means that x plus 12 equals negative 2x plus 6, and y plus 23 equals negative 4y minus 2. Did I write those correctly?
It's not 3x plus 12, it's just x plus 12.
I know, but I just added 2x over.
Oh.
But did I do it right?
I
Yes, I did. Okay. Just making sure because it was going to be a negative number, so I was just making sure. It's okay that x is a negative number as long as it doesn't make the length negative. So if I substitute a negative 2 in, will it make our length negative? Is negative 2 plus 12 negative? Is negative 2 times negative 2 going to be a negative number? So I was thinking that because it was going to be a negative x value, so I wanted to make sure it would still work. That's why. Yes, I know I'm the teacher. I was just making sure that I did everything right. It doesn't hurt to ask. Make sure you're paying attention sometimes too, so that I know. So we get 5y equals negative 25, so y is negative 5. If I substitute in negative 5, will it make either of those values negative? Is negative 5 plus 23 negative? Negative and a negative make a positive, so that also won't be negative, so that one is fine. Please stop talking. We still have 4 minutes. What do you guys know about consecutive angles in a parallelogram? Consecutive angles are supplementary, so let's use that fact here. So I have 5y plus 55 is 180. And 11x plus 5y equals 180. So I have to solve the first one first. So 5y is 125. So y equals 25. How can I find the other one? It has 2 variables. We know that y is 25. Because she's happy all the time.